Hello everyone, I'm Derek Tilley, manager of the Aberdeen Plant Material Center, and today in this video we're going to talk about how to put together a seeding plan and perform seeding calculations. The most important step in this process is to do good site inventories and make sure you have all of the information you need before you start going into species selections and developing a mix. One question to ask before you even get into the process is it really necessary to do a seeding? In our region, especially with sites receiving minimal precipitations, these seedings are risky. Anytime you try to alter the landscape, anytime you do any weed control treatments or seedbed prep treatments or reseeding, there's a decent chance that your seeding is going to fail and you might end up with worse problems than you had before. You could just be making things, better conditions for noxious weeds to come in if you don't get everything right. So we recommend doing complete resource inventory before going into the seed plan development process. Definitely don't just jump into species selection. Look at the site, look at all the aspects, look at everything you need to make good decisions on species selection and implementation decisions. First thing we want to look at is the climate. Probably the number one thing to look at is the precipitation and the high and low temperatures of the site. And when I talk about precipitation, I don't just mean total yearly average, but we also need to look at when that precipitation typically falls. Is it just in the winter as snow? Is it monsoonal moisture in the summer? These decisions will impact the species selection. We also want to do a good inventory of soil, know the texture, know if there's any drainage issues, and we also want to know if there's any chemistry problems with salinity, pH, or is it alkali. Might also need to know if there's been a history of chemical use on the site. All these things can be important and help with your end product. We also want to do a complete inventory of the weeds on the site. We want to know what's there and how much of it. This might be difficult if you're coming into a site after a fire and you don't have a good inventory. So you may have to look at reference sites nearby or make some educated guesses if you can't find someone who knows the site really well. The weed seed bank is one of the most critical things to understand in a seeding. If you don't have the weeds under control, not just at the time of seeding, but also what might come in over the next few years, then you're going to have a problem. We also want to know what kind of equipment is available to us before we do a seeding. Want to know what the landowner is capable of. Does he have seed drills, tractors? Do they know how to operate them? Do they know how to calibrate the equipment? Is it going to be just broadcasting? Is the terrain too rocky for a drill? You want to know all of these decisions up front. Now getting into the plants, you want to consider each species going into the mix, and you want to try to fill all of the different niches of the ecosystem. If you don't do this, then you're going to leave gaps and bare spots in areas where weeds are going to come in. So we want to look at having, plants of different longevities, annuals, short-lived perennials, and long-lived perennials. You want to have colonizing species as well as the climax species. Bunch grasses versus rhizomatous species. This is important for erosion control as well as keeping the weeds out. So you want to have both if at all possible. Really quickly, I'll just talk a minute about some of the benefits, the pros and cons of native species versus introduced species. Typically, we would love to put all native species in all plantings at all times, but that might not be appropriate. If a site is too degraded, if there's too much weed pressure, then the native species tend to have a hard time coming in and competing and getting well established. Introduced species typically have better seedling vigor. They may be more drought tolerant, more resistant to other factors. But on the other hand, introduced species aren't native to the site, obviously, and they're not as good for the ecological considerations. They're not as good for wildlife habitat. They're not as good forage for some of the native species or pollinators for some of the native species. So again, try to do natives whenever possible, but weed pressure and other factors might lean you towards doing introduced species instead, at least for a time. You might be able to come in later and diversify with natives after you've got the site under control. Again, if you consider our natural ecosystems of the Intermountain West, we probably get a recruitment event every 5 to 10 years. So this is a time when in the first summer you've got good moisture, and so the mature plants produce a lot of seed. Then that falls to the ground, and then in the spring there's adequate moisture and good temperatures for a sufficient length of time to promote good germination and establishment. And this only happens, like I said, every couple of years. But with NRCS and other type of plantings, we're on a yearly schedule, and we can't always wait for these good recruitment events, and we don't know when they're going to occur. So sometimes, to hedge your bet, you might want to choose more vigorous drought-tolerant species of the introduced group instead of going with natives. So site prep is extremely important. You got to get the weeds under control, and this isn't just a matter of clearing the site off for your drill. This isn't just, burn it down once with chemicals or with a fire and then go in and plant. We've found time and time again that it takes multiple years to get the site under control, get the weeds under control before seedings are likely to establish and be successful. So both of these techniques or both of these protocols are similar in that they clear off the weeds one way or another, either shredding, burning it, or disking it, and then you keep the weeds under control either chemically or mechanically or both for at least one season, if not 2 full seasons. And then typically we recommend fall dormant seeding on rangeland sites. If you have irrigation available, then you can do your seeding pretty much any time in the summer except when it's extremely hot. But for a non-irrigated range seeding, we do recommend a fall dormant planting. And you can find recommended dates for that in Idaho Tech Note 24. So always follow label recommendations for chemical applications. I'm not going to go into this too much, but just make sure you're using the right chemicals for the site that are specifically labeled for rangeland applications. Keep in mind grazing and re-entry intervals and that kind of thing. You might talk with your extension specialist for help on this. So right now I want to talk about just a couple common scenarios we run into and, kind of the decision-making process for each one of these. So in the first scenario, we've got a low precipitation range site. It's got a good complement of native grasses, but there is kind of limited cover and very few native forbs. So my first thought coming into sites like this is it might be best just to leave it alone. If you go into some serious site prep, with any tillage or chemical control, then you might just be allowing whatever weeds are there to explode and get established and take over the site, and then you're going to have trouble getting better things to come in. If, however, you have some kind of disturbance like a large fire, this might be a good opportunity to throw in a native mix and try to diversify the site. You could also consider doing localized treatments, what we would call a forb or shrub island, um, where you do some roundup of a small area and then do intensely manage small sites to get forbs or shrubs established from where they can spread after conditions get better. Scenario 2, we've got another low precipitation range site. This one is predominantly covered with introduced perennials, probably crested wheatgrass or Siberian wheatgrass, and there's a lot of annual weeds here. So here we would recommend some strenuous site preparation. Again, 1 to 2 years of chemical or mechanical control of everything. If you just do a single treatment of Roundup, it's going to look like you did a good job of clearing the site, but it's most likely just all going to come back. So we recommend a good 2 years. If a good site prep isn't feasible, then I wouldn't bother with natives on a site like this. I would go back into introduced perennials. Scenario 3, this is a higher precip zone, probably up in the foothills or the mountains. We've got a good native plant community. I would probably leave this one alone. Natural suggestion or succession might do the trick. You might just want to leave this for a few years and see where the trajectory leads. You might consider, again, forb or shrub islands. If there's a fire, you might go in and put in some more natives, throw in a diverse forb mix and see what happens. But I wouldn't do anything to disrupt this community. I wouldn't do any tillage. I wouldn't do any mechanical or chemical control unless it was very selective. And then scenario 4, a higher precip site with high weed pressure. If at all possible, I would do something with this site and control the weeds. But you are, in these montane sites like this, you're going to want to consider erosion. Reducing the cover for a couple of years might result in some unwanted erosion. So you need to be able to address that with some kind of either quick cover crop. You might do some kind of introduced forage grass while you're trying to control the weeds. Yeah, this is a difficult site. If it's a post-fire opportunity, then come in with natives. So now we're going to go into developing the seed mixes and sort of our step-by-step process. So we highly recommend looking at the ecological site descriptions to get a good background of information on the site. A lot of times NRCS planners don't have a good relationship with the site before they come in. It's someone else's property. We don't know what the history is. We don't know what the original habitat looked like. It's often been farmed or had some other kind of disturbance for many years. So the ESDs are a good place to get this background information. So here we're looking at a loamy 10 to 13 inch Wyoming big sagebrush site and blue bunch wheatgrass. This is over in the Waihi Plateaus. And you can see here we've got total precip of about 14 inches, which is a good amount of precip for us. That gives us lots of species choices and lots of good opportunities for establishment. And you can see here most of that precip is coming in the winter months. We've got a long dry summer spell, but we do have some good spring moisture we can probably count on and good fall moisture. So this is a pretty good site to work with. And as you go deeper into the ESD, you're going to get the species list that show annual production of pounds per acre. And so if you look here, this is the grass list, and I've highlighted blue bunch wheatgrass. You can see that it makes up the bulk of the grass species here as far as production goes. So we're going to want to take note of that. So our mix is probably going to have a large complement of blue bunch wheatgrass in the end. When we'll probably look at some of these other species, we've got Indian rice grass, which is an easy grass to establish, works well for us. There's lots of seed, it's pretty cheap. We've got some other things. Bottlebrush squirrel tail is available. Thick spike wheatgrass is an excellent rhizomatous grass that we might want to keep in there. Nevada bluegrass and sandbird bluegrass. All of these are available commercially and don't cost a lot. So we'll want to keep all of these in mind. Then we go to the forbs. And so you see, again, this is pounds of production. So none of them are terribly prevalent at the site. You've got a good diversity. But let's go through these a little bit. So we've got pussy toes, an aster, milk vetch, got a couple different balsam root species, taper-tape hawksbeard, larkspur, a biscuit root, lupins, hood phlox, and longleaf phlox. Now, first thing to notice is a lot of these were just identified to genus. So we've got Antenaria, they don't know which species it was, Aster, Astragalus. So if you were to make a species list or a seed mix, you would need to know exactly what species is best adapted to the site. So I would be very hesitant to choose just a random astragalus. If you're going to look at a milk vetch for seeding, you know, the most common one on the market is Sicer milk vetch, which is an introduced species. And so you're not really meeting the ecological site if you do something like that. So you want to know what species, if at all possible. Another thing to consider is a lot of these are very small seeded species and are going to be extremely expensive. So we might want to, we'll keep this list in mind, but we're probably going to make some changes as we go and make our own list. Here we have the shrubs. You can see the greatest portion is Wyoming big sagebrush. We've also got some yellow rabbit brush and some unidentified buckwheat species here, but again, most of it's going to be Wyoming sage. And then keep in mind, sagebrush identification is very important. There's 3 subspecies of big sagebrush and some other species of sagebrush, and each one has very specific requirements and are adapted to specific conditions. So you need to know which species and even subspecies of sagebrush you're dealing with. And beyond that, sagebrush populations even have very specific adaptations. So if possible, you're going to want to purchase seed from the same region or even the same county in some cases. That might be difficult, but it's something to strive for. So if you don't have an ESD, I know there's a lot that are under development or in draft form. So you're just going to have to try to find information about the site from other sources. So probably the best thing, if possible, is to look for reference sites nearby. You can talk to local experts. You can contact herbarium staff at different universities, or contact the Plant Materials Center. We've got a pretty good handle on what the different ecosystems are out there and what species are adapted. So now when you start making species decisions, you're going to want to consider a lot of different things while making the mix. We looked at this a little bit earlier in the discussion. We've got growth types, lifespan, adaptability to different precip zones, different soils adaptations, are they native or introduced? And then you might want to look at palatability, when they flower, that's what phenology is, and then there's a lot of different information you're going to need to know about the seeds to actually perform the seeding itself. We have some good technical references for the field offices. TechNote 10 goes into planning and installation and evaluation of different seedings. TechNote 24 houses all of the species information of the commonly used species for NRCS plantings. So if you want to look at different species and their adaptation and seeds per pound, that kind of thing, TechNote 24 is where to start. There's also a technical note number 2, which is specifically on pollinator species. So if you're looking for different forbs, you can go to TechNote 2. So for example, in Tech Note 24, this is just an excerpt about blue wild rye. You can see we've covered a lot of information here in a short amount of space. It's fast developing, short-lived, cool season bunch grass. It's native, common in forests, semi-shaded areas with 16 inches or above precip, good seed production, rapid stand establishment, gives you planting depth there, and seeds per pound recommended. So you can see TechNote 24 has a lot of good information, and this is just in the species description part. This table here actually comes from Technical Note 2, but you'll also find this information in Technical Note 24. This is a species list broken up by precipitation zone. So this is these are forbs adapted to a 12 to 15 inch precip areas, and you can see we've got several species here. We show when they flower and what color they generally are, native or introduced, seeding depth, how many seeds per pound, recommended seeding rate in PLS pounds per acre, plant spacing. We talk about this especially for shrubs, how far apart they should be planted, and then soils adaptations as well. TechNote 24 has the same types of information. We'll also go into different releases that are more recommended for our area. So you don't want to purchase seed of a release that's adapted, say, to the Midwest and not to the Intermountain West. We also give some purity and germination information, what you should expect to see. This might be helpful if your seed tag is missing or they don't provide this information. It will help you develop your seeding calculations. So a couple rules of thumb we follow for seed mixes. We want to use between 6 to 10 grasses, forbs, and shrubs. For some of our pollinator plantings and cover crop plantings, that number increases. If you want to have really high diversity, that can go up quite a bit. Be mindful of compatibility. You don't want to have, one species in your very expensive seed mix that's going to outcompete everything else and suppress establishment of all the other seeds you purchased. And also be mindful of seeding depth. A lot of times we'll see grasses and forb seeds mixed together where the grasses need to be planted at a 1/2 inch to 3/4 inches deep or even more, and the forbs tend to need to be seeded right on the soil surface. If you try to put them all in one mix together, you're going to not get good establishment of something. A quick note about combining native and non-native species. We generally don't recommend it. Introduced species have much higher seedling vigor, are very quick to establish, and tend to outcompete the native species in the mix. The only exception I would say to that is you can use introduced forbs and legumes in a native grass mix. So for example, you could have native grasses and add alfalfa or sandfoin or Sicer milk vetch or Delar small burnet to those mixes, and they'll be fine. Those work out very well. Some other things to consider: expected lifespan of different species. Some species will live just a short amount of time and then die off and make way for other species. So you wouldn't want that, a species like that to comprise the bulk of your mix. You'll just end up with not much cover later on down the road. Think about the ease of establishment. Some things are just difficult to get going. Maybe you want to eliminate them from the mix. The seed's physical characteristics can be important. Sometimes seed comes with appendages, or might have an awn on the grass seed, or might have a fuzzy coating. Those kind of things tend to make seeding equipment bridge or reduce the flow of the seed. So you might want to consider an inert carrier like rice hulls or kitty litter or sand or something like that. Also, legumes should be inoculated with the proper rhizobium. We have a tech note describing that process and how to make those selections. So based on all of those considerations, I've put together this mix. Now keep in mind, there's not one right mix and all the other mixes are wrong, and percentages, don't have to be something that's agonized over. You don't need to, have 1.5% of certain forbs, and I like to keep things very, very simple. So, basically here we've got a large component of blue bunch wheatgrass. I put it in at 40%. Indian rice grass at 10% because I know it's going to do well. Then we've got some of the other grasses at 5%. We've got Nevada bluegrass, thick spike wheatgrass, again, which is rhizomatous, so I wanted that in the mix. Slender wheatgrass is one of those colonizing grasses that comes in for a couple of years very well. So we've got it at only 5%. It's going to help us capture the site, reduce erosion, and pave the way for the longer-lived natives to come in. And then we've got 3 different forbs, Lewis flax, yarrow, and Palmer's penstemon. And remember, these weren't on the ESD, but I went through Technical Note 2 and Technical Note 24 to find different species that were adapted to those conditions, the moisture and the soils and everything else. And I came up with these because I know they're abundant, they do well, and they're relatively cheap. I put in winter fat, which is a shrub. It's very good for winter grazing. And then Wyoming big sagebrush, which was a big part of the ESD at 10%. So now we're going to go into making the seeding calculations. The first thing we want to talk about is PLS, or pure live seed. Everything that we do, all of our calculations are based on pure live seed. And this just means this is the seed in a bag or in a lot of seed that is actually healthy, going to germinate, it's not broken, and it's not inert material. So in the picture you can see you've got some inert material here. There's some stuff covering the seeds. So first thing we're going to do is look at percent purity. This is the weight of all of the seed minus inert matter and weeds and other crop seed and anything that isn't a good seed. So that's our purity percentage. Most grasses, I say here, shouldn't have more than 15% inert matter, just something to keep in mind. And then if you multiply your purity times your viability, which comes from a germination test, that will give you your pure live seed. So as far as viability goes, again, it can be done with germination tests in a lab. So this is the percent of normal seedlings that you would get in good conditions. And then you can also look at total viable seed, which is the germination plus hard seed or dormant seed. And you can have a special test conducted called a tetrazolium test, which stains a good healthy embryo red. And so if you look at all of the seed that is healthy and then subtract your germination, you can determine how much hard or dormant seed you have in the seed mix. So once again, PLS is percent purity times percent germination and divided by 100. So if you've got purity of 99.5, germination of 90%, your PLS, your pure live seed, is 89.5%. And this can become important when pricing out seed. You can see here we've got 2 lots of seed, lot A and lot B. Lot A is very good purity, has good high germination. PLS, if you do the calculation, is about 89.6. And if you're basing this on $1 per pound of bulk seed, then you're paying $1.12 per pound of pure live seed. Now in comparison, lot B has slightly lower purity but much lower germination. And so the PLS has dropped dramatically. So if you make this comparison, you're actually paying quite a bit more for lot B for the same amount of seed. Now, to compute the bulk seeding rate based on PLS, it's pretty easy math. So we're going to do the PLS seeding rate, which is the recommended rate that you'll find in Tech Note 24, and divide that by the percent PLS. So for example, we've got Goldar Blue Bunch wheatgrass. The recommended rate is 8 pounds PLS per acre. And this lot of seed has been calculated to have 89% pure live seed in it. So you divide 8 pounds by 0.895 and you come up with 8.9 pounds bulk. So what that means is to apply 8 pounds of pure live seed per every acre, you actually need to put on 8.9 pounds of the seed that you've got from the commercial vendor. Couple rules of thumb for seed quality real quick. Grasses should have pretty good germination rates. Above 80% is normal. If you find a lot of seed that has lower than 60% germination, be very careful with it. You can adjust your seeding rate based on this, but if the germination has decreased that much, you might be looking at seedlings with lower vigor. There's going to be something wrong there, so you might have poor establishment. Native, source identified, wildland collected grasses, forbs, and shrubs often have low germination rates and very low purity, depending on the lot. Germination will decrease with age. That will depend somewhat on storage, but typically we just recommend to avoid older seed lots, and all of this can be solved with current germination tests. We recommend having a germination or a TZ test within the last 12 months. And then some species can lose their viability very quickly. Sagebrush, forage cushion, winter fat are classic examples. These drop in viability very drastically after 2 years, and sometimes even after a couple of months. So make sure you have recent tests, especially on those. NRCS Idaho has developed its target seed rates based on these equations here. So if it's what we would consider a small seeded species, meaning there's more than 500,000 seeds per pound, then we recommend 40 to 50 seeds per foot get seeded. If it's a smaller seeded species with fewer than 500,000 seeds per pound, then we recommend about 25 to 30 seeds per foot. This is based on the idea that larger seed typically has better vigor and is easier to establish. The smaller seeded forbs and things like bluegrass typically have low vigor, and it just takes a little bit more seed to get adequate establishment. So here, for example, we're going to talk about groundsel, the genus Senecio, which I've been working on recently, has about 900,000 seeds per pound. So for that, we're going to be up in this small seeded group, and we're going to shoot, we're just going to use a target of 50 seeds per foot, multiply that times 43,560 square feet per acre, divide that by the 900,000 seeds per pound, and you come up with about 2.5 pounds per acre to hit this rate. And these calculations have been done for all of our commonly seeded species in our tech note. So when you go into the tech note and see the recommended seeding rate, that's just based on these calculations. So here we get into the actual calculations. So this is our mix from earlier. We've got, again, 40% blue bunch, 5% sandberg, Nevada bluegrass, 5% thick spike. We've got 10% slender, Lewis flax yarrow, winter fat, and sagebrush. Now these should add up to 100%. If you're going to make seeding rate adjustments, don't change the percentage because your percentage can't be more than 100%. You would change the seeding rates over here. So if I've got this right, we have 100% in our mix. I've included seeds per pound from TechNote 24. You don't need these if you have these calculations already done. But I'm just going to show what this actually looks like as you go through. So these are the full stand seeding rates from TechNote 24. This means if you were to plant just blue bunch wheatgrass, just 100%, we would recommend 8 pounds per acre to get that 25 to 30 seeds per foot. Nevada bluegrass is 2 pounds per acre, thick spike 8, slender 8, Lewis flax 5, yarrow is a half a pound, winter fat 2 pounds, and sagebrush at a half a pound. So again, if you were to follow this recommendation based on the calculations, this means you've got 25 seeds per foot or 50 seeds per foot of the smaller seeded species. Just in general, I put that in here. So to get your actual pounds per acre, you're going to multiply this, the full seeding rate, times the percentage. So 8 times 0.4 is 3.2. So in our mix now, we're going to put 3.2 pounds per acre of blue bunch wheatgrass. And then, 0.1 pounds of Nevada bluegrass for our 5% of the mix, and so on and so on. And if we do those same calculations based from the seeds per foot, then we end up with 10 seeds per foot of blue bunch wheatgrass, 2.5 seeds per foot on average of Nevada bluegrass, and so on. And our total is about 31 seeds per foot of our whole mix. Some adjustments you might need to make. We recommend increasing the seed rates 1.5 to 2 times for broadcast seeding, and again 1.5 to 2 times for a critical area planting. So yes, it is possible that you could seed 4 times the recommended rate. And finally, the pounds per acre are based on 12-inch drill spacing or straight broadcasting. If you've got a drill that has spouts either closer together or farther apart than 12 inches, then some adjustments are going to need to be made. Technical Note 24 at the very end has these calculations to adjust those seed rates. And finally, we've put together a seed mix calculator in Technical Note 7. And there's a web link to it on our web page. And so you can see here we've given our project the name Plant Materials Workshop 2020. We're going to seed 100 acres. And this is our seed mix. We've got the different percentages entered here. We put in the recommended full seed rate from TechNote 24. And then we've put in the percent PLS, which is based on the seed tag that comes with your seed. If you want to, you can also put in the bushel weights of these species, and that will help come up with the amount of inert carrier that we would recommend to put in that seed mix. And from that, this calculates the total amount of seed needed for your 100 acres of bulk seed. So for your blue bunch wheatgrass, you're going to need 390 pounds, and so on and so on and so on. This also provides a drill calibration calculator. So if you can enter your drill width, the length of your desired test run, and the number of drop spouts of your drill, then this will calculate how many grams of this mix per spout you should shoot for to calibrate that drill accurately. Again, this is all in Technical Note 7 and linked on our webpage. That's all for this video. Thank you very much and happy seeding.